Hello everyone, this is Prashanth. Let's continue with the last lecture in the Internet of Things. This is the class for question bank discussion on unlock digital converter, digital to unlock converter, and voltage sensor sensors. So in the previous class, just we have completed a question bank discussion on machine to machine communication. Machine to machine communication and M2M and IoTs. What are the main specifications of M2M and IoT, and what are the main differences between in terms of different parameters? Just we differentiate M2M and IoT. So these are the things just we have completed in the last lecture. So now we move entering into the again same question bank discussion on the voltage sensors, voltage sensor, analog to digital converter sensor, and digital to analog digital DAC, digital to analog converter, like that. So let's start with the here we have Internet of Things. These components play a crucial role in the gathering and manipulating data from the physical world. So here how they contribute to the core principles of IoT or Internet of Things. So here the voltage sensor here, what are the objectives and what are the outcomes here? The objective is here continuously monitoring health and performance of devices by measuring the voltage levels in critical components like batteries, power supply, like that. This is the objective of voltage sensor. Next, apart from that, we have outcomes also. It enables the real-time data collection for preventive maintenance, optimizing energy usage, and detecting potential malfunctions connected of the devices. So these are the voltage sensors objective and outcome. So here we have analog to digital converter and digital to analog converter here. Analog to digital converter, what is the main objective of this is bridges the gap between the physical digital worlds by converting sensor data into format understandable by digital devices. So this is the analog to digital converter objective. So based on that, we have outcome also. Allows integration of various sensors like temperature, pressure, and light into the IoT ecosystem, facilitating data collection and analysis for better decision making. So these are the main objective and outcome of analog to digital converter sensors. And digital to analog converter sensor, what is the objective? It is enables two-way communication in IoT system. It will translate digital instructions from a central hub into the physical actions. And the outcome, it allows control of actuators like lights, wheels, motors based on sensor data or user input. This is creates a feedback loop for automation and remote control in smart homes, industry, and connected environments. So these are the objective and outcome of different sensors, analog to digital converter and digital to analog converter. So next we move entering into the what are the DTH temperature and humidity. Along with that, we have different sensors also like DHT11 temperature sensor and humidity sensor. These are the remaining two DHT temperature and humidity sensor. What is the main objective of this? Gather environmental data like temperature and humidity, crucial for various IoT applications. And outcome, it provides real-time insights for applications like smart agriculture, optimizing irrigation system, controlling heating and cooling, remote patient monitoring, ensuring comfortable and safe environments, like that. These are the objective and outcome of the DHT11 temperature sensor. And these components combined with other IoT enabling technologies also. Apart from that, connectivity, data acquisition, and automation and control. So here, sensors collect data and ADCs convert into it for transmission and access networks. The data acquisition, continuous monitoring provides valuable insights into device health and environmental conditions also. next to automation and control, the DAC is digital to analog converter translate the digital instructions into actions, allowing for remote and automated responses based on the sensor data. So these are the some components of DHT level temperature, like connectivity, data acquisition and control system. So remaining we have here a voltage sensor to uh, voltage sensor in the real time of IoT, Internet of Things. Voltage sensor can play a crucial role in monitoring and regulating electrical system. Here's breakdown of how they work and how you can leverage them into your IoT projects also. Understanding of voltage sensors, basically here we have voltage sensors are devices that detect and measure the electrical potential difference between 2 points in a circuit. So that is on the point of understanding voltage sensor. And they come in various types, each with its working principle. Resistive voltage divider, the simple circuits use resistor to create a voltage proportional to the input voltage, suitable for lower voltage ranges also. And transformers, they used for high voltage AC measurements. These isolation and step down or step down transformer for safe and accurate measurement. So these are the resistive voltage dividers and transformers. Just to it converts from AC to AC only. Depends on the requirement. Just we have use a step down transformer or step down or step up transformer. So here next we have some effects also. Hall effect sensor, optocoupler. These are some parameters of voltage sensor. The contactless sensors can detect changes in magnetic field generated by current flow, enabling voltage measurement without physically connecting to the circuit. So that is the Hall effect sensor. The last one, optocouplers. So here these isolates the sensor from high voltage circuit using light, ensuring safety and accurate measurement for AC and AC or DC voltage. So this is the under optocoupler. The applications of voltage sensors in IoT, just in order to develop some IoT real-time IoT projects, just we may use a voltage sensor that depends on our requirement. So here the battery monitoring, solar power system and smart grid management. So here battery management, IoT devices can use voltage sensors to track battery health, triggering alerts from for low battery for or replacement of needs. The solar power systems monitoring voltage output from solar panels helps optimize energy production and to identify potential issues also. And the smart grid management. Here the voltage sensors in power grid enable real-time monitoring, allowing for efficient power distribution and identifying the potential problems in the IoT system. So these are the some applications of voltage sensors in IoT, battery monitoring, solar power systems and smart grid management. So here continue with that, the industrial application also, one of the application monitoring voltage levels in machines, how much voltage it will take as input or it will give output. Is there any power fluctuations in the flow of current to the machine? Like that, the major things it can be tracked in voltage levels in the machine, process that helps prevent equipment damage or ensure optimal performance, like that. So this is the last one application, integrating voltage sensors with microcontroller also. So here the chosen sensor type determines the connection method, depends on the voltage. Resistive voltage divider provides an analog voltage output readable by the microcontrollers, analog to digital converter, and the transformers or Hall effect sensors or require additional amplification or signal condition circuits for compatibility with microcontrollers ADC. And the optocouplers provide a digital output, simplifying integration with the microcontroller. So these are the some integrating voltage sensors with microcontroller. It can dump program. So here the next one, microcontroller code for voltage sensor. Here the code reads to the voltage data from the sensor, that is analog or digital in nature, and depending on the type of sensor, the calculations might be need to convert the reading to the actual voltage level based on voltage divider ratios or sensor specifications. And this voltage data can be used for various purposes, displaying voltage readings on an LCD or sending them to the cloud for remote monitoring and analysis. The triggering alarms are control actions based on voltage thresholds. That is example notifying users for or high voltage fluctuations like that. So these are the some code process of microcontroller code to voltage sensors. Next, safety considerations. Here we have to maintain some safety considerations. Working with high voltage can be very dangerous. If you are not comfortable with electrical circuits, just you can consult a qualified electrician for projects involving the mains power. So this is the main thing you have to remember in order to do the just you can to deal with high power. So just better to maintain some precautions also. Allows follow the safety precautions when working with electrical circuits, including proper installation and avoiding overloading circuits also. The choose voltage sensors with appropriate voltage ratings. For 3 just input voltage 3.5 volt to maximum 5 volts. Just this is within the range only the sensor it may be work. 3.5 is the low, below 3.5, below 5 volts, like your voltage ratings for your application to ensure the safe operation. So these are the some safety conditions in order to develop the IoT projects. These are the some learning resources of voltage sensor. Search, just you can search in the Google voltage sensor with Arduino or voltage measurement for IoT devices. You will find a tutorial explaining different voltage sensor types, connection methods, code example, and project ideas. Not only voltage sensor with Arduino topic, it may display some other projects also, some real-time other projects also. You can practice with them, no problem. Starter kits for microcontrollers sometimes include voltage sensors or components to build voltage divider circuits, allowing you to experiment with voltage measurement in a safe and controlled environment like that. By incorporating voltage sensors into your IoT projects, you gain ability to monitor and manage electrical systems and effectively. These opens door to various applications and to develop some real-time IoT projects also. So these are the learning resources on voltage sensor. Next, to unlock to digital converter, digital to unlock converter. So here in this principle Internet of Things, the analog digital converters or digital to analog converters play a vital role in bridging a gap between the analog world and the digital world of microcontrollers. So here analog digital converter means it converts a continuous analog signal into digital representation of microcontroller can understand, like whatever the information like voltage or current or temperature or light intensity, it can convert and unlock to digital. That means, for example, here this is the some information like 2 volts minus 2 volts upon 4 volts signal. It can be converted into a digital form, digital in nature, discrete form like that. So by using sampling techniques. By using sampling technique, just we can convert analog signal into discrete time signal. Based on that, just it is converted into pulse signal or digital signal. The digital representation of a series of bits is zeros and ones. We already know the number of 0. This is 1. No. This is 1. This is 0. 1. This is 0. Like that, the number of bits determine the resolution of the conversion. With more bits offering high precision of the signal. Next to DAC applications of ADC in IoT. So here we have different applications: sensor data acquisition, environmental monitoring, and audio processing of the information. So here most sensors, output signals, analog signals, ADC are essential for converting this sensor data, voltage or current, into digital values readable by the microcontroller. This data can then be used for processing, control, and data transmission. And environmental monitoring, ADCs are used with temperature sensors, light sensors, or air quality sensor to convert real world environmental conditions into digital data for monitoring and analysis. Audio processing. In audio applications, ADCs convert analog audio signals from microphones into digital data for processing, storage, or transmission. So these are the some applications of analog to digital converter sensor, data acquisition and environmental monitoring, audio processing of the signal. So next, just we move into the digital to analog converter. Just it is a it can convert from digital signal to microcontroller into analog signal form, that is voltage current, nothing but ones and zero, 1010, just it is converted into continuous time signal, that is analog signal or analog signal. Applications of digital to analog converter in IoT: signal current, audio signal generation and industrial automation. So the signal convert is nothing but it is used to control actuators like motors, speakers or LEDs by converting digital control signals from the microcontroller into analog voltage or current levels that the actuators can understand. And analog audio signal generation: in audio systems, the DACs convert to digital audio data into analog signals for driving speakers or headphones. And industrial automation, DACs are used to control industrial process by converting digital control signals from microcontrollers into analog audio or voltage outputs to regulate valves, pumps and machineries. So these are some applications of digital to analog converter: signal control, audio signal generation, industrial automation. Next, some key considerations of for using digital to analog or digital to analog to digital or digital to analog converter sensors: resolution, sampling rate and audio voltage or current to range. So here the resolution in terms of high resolution ADCs and DACs can provide more precise conversion between analog and digital signals, crucial for application demanding high fidelity. Example, audio processing. And sampling rate also, just I already told, in order to convert analog signal into digital signal, just we use one technique, that is sampling technique. Fs is greater than or equal to 2fm, the condition for converting analog to digital. The sampling rate determines how often the analog signals is converted into digital value. A higher sampling rate is necessary for accurately capturing fast changing analog signals. That is the main thing you have to remember in sampling rate. That is the key consideration to convert analog signal into digital signal. And voltage, output voltage or current range. The DACs have a specific output voltage or current range. Choose a DAC that can provide the appropriate signal level for your application. So this is the some key consideration: resolution, sampling rate, output voltage or current range. And these are the some learning resources to analog to converter ADCs with Arduino or DACs with Raspberry Pi. You will find tutorials explaining DAC or ADC functions, interfacing them with microcontrollers, code or idea projects. And not only with this, it can display many more IoT real-time projects also that may helpful to design some other IoT projects. So these are the some learning resources of ADC and DAC. Next, temperature and humidity sensor. So here DHT sensor, DHT11 sensor. DHT11 sensor is a popular choice for measuring temperature and humidity in various Internet of Things application. Due to its low cost, ease of use, compact size. Here's breakdown of how it works and how you can integrate with your IoT project. So the understanding of DHT sensor here, it is a digital sensor, meaning it outputs a digital signal containing with the temperature and humidity data. It uses two main components for sensing. A capacitive humidity sensor measures the amount of moisture in the air by detecting changes in the capacitance, and a thermistor measures temperature by detecting changes in its electrical resistance. So this is the some specifications of DHT11 sensor. And sensor has a limited measurement range and temperature between 0 degrees centigrade to 50 degrees centigrade with an accuracy of plus or minus 2 degrees centigrade. And humidity, 20% to 80% with an accuracy of plus or minus 5%. So some benefits of DHT11 sensor. Low cost, it is just highly affordable compared to other temperature and humidity sensor, and easy to use. It just we may use in the circuits also. Simple 4-pin interface for connection to the microcontroller, and digital output. No need for complex analog to digital converter circuit. Completely it is on digital, so no need to convert any type of conversion, or no need to any use converters, ADC or DAC converter. And compact size also ideal for space constrained IoT projects. So these are the some benefits of DHT11 sensor, and connecting DHT to the microcontroller. So here these are the some specification to connect to the microcontroller DHT11 sensor. DHT11 typically uses 4-phase interface, just to be only 4 pins it having. One is the ground, one is the input, one is the output, second one is the input voltage. So that is the like four pins. VCC, ground, data, not connected. Very simple. So just 4 pins like here, VCC, ground, data, not connected. And a pull-up resistor typically just 4.7 to 4.7 kilo ohms to 10 kilo ohms is connected between the data pin and power supply to ensure stable signal levels like that. These are the some points. DHT11 sensor connected to the microcontroller, and reading data from DHT11. The microcontroller initiates the communication with the DHT11 by sensing a specific start signal, and the sensor responds to transmitting a digital signal containing temperature, humidity data encoded as a series of bits. And the libraries like DHT library for Arduino simplify communication and data decoding. Last, the applications of DHT11 in IoT. Environmental monitoring, smart agriculture, smart homes, and IoT wearable. So here environmental monitoring is nothing but it monitors the temperature, humidity in homes, greenhouse gases, weather stations for data logging and control purposes. And smart agriculture, optimize irrigation systems and control ventilation in greenhouses based on real-time temperature and humidity readings like that. And smart homes, adjust thermostat setting or triggering dehumidity defines based on temperature and humidity levels for improved comfort and energy efficiency. So this is the smart homes. And IoT wearables also track body temperature and humidity for health monitoring applications. So these are the main applications of DHT11 in IoT. In order to develop the IoT real-time projects, just we may use this fact, depends on this factor, just we may use as per our requirement. Environmental monitoring, smart agriculture, smart homes, IoT wearable devices like body temperature, humidity for health monitoring system. So these are the some limitations of DHT11. So compulsory we have some limitations. Limited measurement range, it is not suitable for high distance or high range of applications, and slow sampling rate. So the sampling rate is high, just the analog signal can be converted into digital in very fast manner. So but here there is a sampling rate is very low. No external power supply, so there is no connect requires a microcontroller to provide or power limiting to use a battery powered application. So here no power. Generally the microcontroller needs a separate power supply to perform the task. But here there is no power supply to the DHT11 sensor. That is one of the limitation of DHT11 sensor. So alternative to DHT11 sensor, just we have some alternatives. DHT22. In place of DHT11, just we may use DHT11. Just these two are similar features in order to use any developing of any IoT projects. Offers a wide measurement range, higher accuracy, and is slightly more expensive. Just we may use in place of DHT11. And AM2302 similar to DHT22, but it provides additional features like status detection also. It is having some more extra features to detect the data. Next, BMB280 combines temperature, humidity, pressure sensing in a simple package, ideal comprehensive environmental monitoring. So these are the three DHT22, AM2302, BME280 alternative for DHT11 sensor. And the learning resources of this DHT11 sensor. It is just you can type DHT11 sensor with Arduino or DHT11 tutorial. You can find numerous tutorials explaining the sensor operations, code examples, project ideas, connection methods. Not only with this, it can display automatically many more some real-time projects also that may helpful to develop some other IoT real-time projects. So by understanding of this DHT11 sensor and its application, you can create IoT projects that are sensitive to environmental conditions and allowing for more intelligent and responsive systems. So this is the main significance of DHT11 sensor. So we have some alternatives for DHT11, DHT22, AME2302, BME 2802, like that. We have some alternatives for DHT11 also. In case of failure to use DHT11, just in place of that, we may use these three type of sensors to developing the IoT projects. So these are the question bank discussion on the analog to digital and digital to analog converter with voltage sensors. Remaining continue with the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.